for my future Minecraft. This will be the prerequisite video for my future Minecraft logic visualizations videos, which I'm planning on doing. And here we'll be going over some of the basic logic gates and how can we build them in Minecraft and what do they do in the first place. And the idea of this series is to pretty much have a better understanding as to what is going on through the signals, because even if I have breadboards, I would have to like put LEDs and stuff along the ways. But here in Minecraft we can have a pretty good visuals because we can see the redstone light up and we can just kind of see where everything is moving, what's going on, and all that kind of stuff. And I think that'll be a good way to have just a better understanding of the logic gates and flip-flops and such and whatnot, and just be more comfortable building them and just kind of knowing what to do. So let's get right into it. I'll start with the most simplest one, which is an inverter or a NOT gate. As you can see, the lamp is on when I don't have a signal, and so the redstone is off. When the lever is pointing up, it's off, and if I turn it on, the lamp turns off. So this is a simpler, pretty simple inverter. Here I have a small visualization as well. There's two good ways of building the NOT gates in Minecraft. And the one that I usually do is to just kind of have a redstone torch on the side of a block, and it will get powered off by the redstone. And if it's off, this will be on, and so we invert the signal. But if you pay close attention, the piston is actually just a tiny bit faster than the redstone torch. See that? This one turns on and off just a tiny bit faster. But this kind of goes, I don't know, like in a letter L, kind of, I don't know. But this we can build linearly, which is pretty helpful in your redstone circuits. So you just have like you can even have your redstone torch up top and it'll turn off, and you can run the signal. But be careful doing it like this, because you can get sort of butt powered. So if you just put it on the side, and that's perfectly, it takes up, well, really 2 blocks of space, or even 1, because this is already inverted. And it's reasonably fast, so that's what we'll be doing. So that's the inverter, but now let's get on to some fun stuff. So what I'll do is I'll just go through the truth table, and then you guys can try to take a guess which kind of gate is that. So when both are off, the redstone lamp is off. If we turn one, it turns on. This one turns on, and if they're both on, it is still on. So the idea here is that if either one, if left or right is on, the redstone lamp is on. So this is the OR gate. But now, as you guys may think, if it's an OR gate, what should happen when both of them are on? Obviously, in this case, we can see that it's on, but does it make sense? We'll get to that later. To build that, it's really simple. Say we have 2 inputs. Hi there. And we can just run the line across like this, and we'll get the desired behavior. Yeah, go away. But the problem with this method, say you have like a lamp right here or something. There's like another redstone circuit, and the circuit from this side is powered on. You can accidentally power what you don't want to power. So it's better to sort of isolate it with some repeaters. Do kind of like that, maybe. And this way, yeah, it's not gonna get powered when you don't want it to be powered. What am I doing even? Hold up. Yeah, kind of like that. So we'll still achieve the OR gate right here, but we don't power this redstone lamp. Alright, so OR gate is super simple. You probably have used it before. but it's not that interesting as this guy right here. And I'll just tell you right away. So this is the AND gate, and for it to turn on, both the signals have to be on. So if I just turn one, nothing is happening. If I turn the other, nothing is happening. But when left and right is on, this is how I remember it. Left and right is on, the redstone torch is on. There's also a few ways to build it. The one that I came up with like pretty long time ago, it's very simple really. So you just have a piston, and then say this is the redstone line, and we have two inputs, and the idea is if this is on, unless this guy is on, the signal should not go through. And we can achieve this by just having a block. So what this will do is disable the path, and no matter the state of this, the redstone will always be off. When will this guy despawn, by the way? I guess he's also interesting to learn about logic. And so you can clearly see sort of the main feature of the AND gate, which allows the signal to go through. If one is on, the other one just goes through. Or not. There you go. So you can use this as like a on switch maybe. Maybe this is some kind of circuit and you don't want it to go farther until you say so. And this is how you would use AND gate. So now these two, as you can see, they're on when they're supposed to be off. So these are NOR gates. So there's NOR and NAND. So this particular one, can you guys tell? Is it a NOR or NAND? Yeah, so it's a NOR gate. When one of them is on, one of them is on, the redstone lamp is off. So it's just kind of reversed like this. And to build it's honestly quite simple. As you can see, I just have the OR gate right here, but I invert the output at the very end. Super simple. Now NAND gate, it's pretty special. Now these two gates are special. If you guys heard it before, they're what's called a universal gates. And the idea is that you can build any kind of circuit using simply these two gates. As you can see, I have a lot more, but you can achieve all of that functionality just with these two guys right here. So they're the universal NOR and NAND. And NAND is built in a different way from, you'd think that to build a NAND gate, kind of like we did with a NOR gate, we'll build like an AND gate and then we invert the output. So it'll be the AND, and then you put a NOT, and you'll have a NAND gate. But no. Let's take a look what is going on over here. Completely different. So let me just show you very quick how it works. So in Minecraft, we can come up with this kind of creation, and this can be extended as long as you want. Now let's look what's happening closer. So now both of these are off. This is off, this is off. It goes into the redstone torch, which is always on. Now both of these should be always on, and therefore the lamp is on. If I turn one of those guys off, the other one is still on. Now this way, maybe if I had more inputs, I'll have to turn every single one of the inputs off, and the lamp is going to be off. So as you can see, there's no AND gate here. It's a special NAND. And in fact, in real life even, the way you build a AND gate is by actually first constructing a NAND gate. So essentially, an AND gate is a not NAND, if that makes any sense. So if I just rebuild this construction right here, so I have two redstone torches. In this case, I'll have just a redstone line in between. I'll have the two inputs, kind of like that. And what I'll have to do is simply invert the output, and all I have is an AND gate. If this is on, and only when they're both on, the redstone lamp is on. So this is, yeah, how it works in real life. It's not how you think it would be, but it's way more compact than building pistons. And this is just the good way to go. Even though this might be a little faster, as I showed you with the pistons, you have this awkwardness with it being not exactly linear. Well, this is pretty linear, and the most importantly, I can have multiple inputs. I can just scale it up as much as I want. Maybe if I put it like this, one turns off, but then I have to connect everything here as well. It'll have to be connected. And then I could invert this. And here I have a multi-input AND gate. Okay, well, anyway, now that we know some gates, let's try to actually build something useful. So remember how I guys told you about the OR gate right over here, and what will happen when both of them are on. Some may argue that the lamp should be off, because if it's an OR, we're only looking at the difference. We want them to be different. But in this case, it doesn't quite help when both of them are on. The redstone lamp is on. So here's the special guy, which is called XOR, or exclusive OR gate. And as you can see, when both inputs are on, the redstone lamp is still off. And only when they're different will it turn on. Now let's think about how we would, what exactly do we want first of all? So we want when left and right are on, oh sorry, left or right, but not both. So left or right, and not left and right. See what I'm saying? So what we can do is we can create two different gates. Let's not dig inside over there just yet. So let's try to come up with a circuit just right now. Let me get rid of this. So what we want to do, so we have two inputs, left and right. We want to do left or right and not both. So first we need to do an OR gate here, and let's just do it kind of like that. So this would be ORed, and we'll need an AND gate, and not both. So we'll need an AND gate and a NAND gate, right? So I'll have to get this input on the other side, is I think what I want. So let me just kind of do it like this. So yeah, kind of like that maybe. So I'll need a NAND gate right over here. Let me put this up. How can I do this? Just so that you guys can understand it better. I actually do it like this, I think. Okay, so here we have a NAND. So we need left or right over here, and not left and. So this is our OR, this is our not and we just need to AND them together. So for the visual sake, I could use a piston maybe. I could do like a piston right over here. Oh, what the hell? No, it's not compact at all, but I'm building it for the visual sake here. And let me put redstone lamp right over here. And now let's see if we have what we need. Left, yep. Right, yep. And now what happens when both of them are on? Perfect. You have achieved our design functionality. So let's see what exactly is going on when both of them are on. So they're getting ore together. Then they're getting non-ANDed. Then the off signal goes to this piston and it disables the ore. And it will only disable when they're together. And I think that makes total sense, because from the OR gate, we only need to disable the very last one. Because this is obviously pretty close to the desired functionality. We just need to disable the very last one, which is AND. As we can see right here. So we just need to sort of combine these two and make sure when this is on, this signal from here doesn't go through. And that's exactly what we have here. The signal doesn't go through when this is on, or well, off rather, because that's why we have the NAND. All right, well, I hope that made a little sense. Actually, I hope that made a lot of sense, and then we'll be ready to tackle on some of the more exciting stuff. So this is just the prerequisites on how to build the gates. And by the way, this is the compact way. We can take a look here as well. So here I just have a piston, there's two repeaters, and then yeah, so both, it's the same functionality really. When both of them are on, we are not allowing the signal to go through. So you guys can, it's a good idea to try to come up with them yourself, but you can also refer to like a Minecraft Gamepedia, where they have all sorts of gates. Like there's a lot of ways to build pretty much every single one of those guys. So I showed you some ways for like an AND gate maybe. There are other gates to do. And also I want to do like a tiny little disclaimer maybe at the end of this video. What I'm doing, it might not be the most efficient way to do in Minecraft. The goal of this is to visualize logic, how it would be quote-unquote in real life, like pretty much using only these gates. If I open the redstone tab, like there's a whole bunch of stuff that we can use. We can use like null blocks, we can use dispensers, hoppers, lecterns. We also completely ignoring the fact that the redstone has different levels. We're just thinking of it like on and off, but it has different levels which we're not using. We're not using comparators, observers, which is a big thing in modern Minecraft. Observers, very big thing, which we are not using. They could make for a quite more compact logic gates and other schemes in Minecraft the game, but we are wondering just using these two. Pretty much all I have in my inventory, which is a redstone torch, a repeater, an on-off signal, maybe a piston, but as you guys can see, we don't even have to use pistons, so really just some redstone torches and I don't know, blocks. And yeah, this is to kind of represent the real life, and the goal is to use 2D, but yeah, we are allowed to use the 3D space, but yeah, nothing more. So if you guys are looking for like good ways to learn Minecraft redstone schemes, this might not be the best way because we are quite inefficient, but this is how it will be like on a breadboard, and it works pretty good, and we'll see better when we come to flip-flops and stuff. All right, see you next video.